Hello. Hey everybody. Give a minute for everyone to join. Who's here so far? Oh, maybe I need to add them. Wait a minute. Hello, Shriram.
Hi, good morning, Karan. How are you doing?
Good, thanks. How are you?
Good. Sorry, I didn't have time to finish the assignment, but I'm still excited to join and continue on uh, today's session where we're going to work.
Nice.
So,
Yeah, no
uh,
worries at all.
yeah, sorry, I've been slammed with like a bunch of assignments. I think that'll clear up this week, and some of the traffic will get unblocked. I think it's kind of signed up for too much work, and now I'm kind of suffering because of that.
Yeah, I know that feeling. Hey, Adil. Hello, hello.
Hello, everyone. Hi, Karan. Hi,
Hi, good
Sriram.
morning.
Hi, Nita.
Hi, good morning.
How are you all?
Good.
Good. Good, all is well.
All right.
All right.
I think we can get started.
Start.
Yeah, so we've got a couple people on the live stream. Let's see. Hello, everyone. I'll be checking the chat, so feel free to drop notes, drop questions. All right, we've got Sriram, Adil, and Nita today. Let's dig in. Oh, I have to share my screen over there. Now y'all can see this screen in the meeting. All right, welcome to episode 4 of Get It Right in Black and White. Today, what we're going to do is use D3 to reproduce this Sol LeWitt piece in its fullness with different shapes. What we'll cover includes a review of the exercise submissions from last week, and then we're going to start using D3 selections and data joins. We're going to take what we did last week and refactor it, move the code around, change it so that it does the same thing but uses D3. And then we'll look at D3 symbols. D3 actually provides these nice shapes that we can use. And along the way to reproducing that Sol LeWitt piece, we're going to talk about SVG group elements, translating group elements, meaning moving them around, and we'll touch upon D3 point scales and potentially band scales, depending on how far we get. All right, so this is the Sol LeWitt piece that we're aiming to reproduce. And today, what I'm hoping to do is get to the point where we have multiple different shapes in this mask. And if we get to that point and still have time, I want to tackle the problem of the background being different for each of these. I think the first pass would be, the background is all vertical lines and the filled in shapes are all horizontal lines. That would be the first phase that we're going to shoot for. So phase 2 would be to make it so that each square here has the the horizontal lines in the background and the vertical lines in the foreground, alternating with the vertical lines in the background and the horizontal lines in the foreground. So, I don't know. I hope it's not too ambitious. Let's give it a shot. Right, so let me pull up the exercises from last time. All right, here's the forum post from last week. Let's see what we've got. Philippe Mayon, he's been following, and I'm very impressed by this work. This is actually a game. Check this out. It's my face with, this Sol LeWitt-esque kind of a thing going on. Pretty wild. And it changes over time. I'm just blown away by this. Very nice work. Yeah, and I think he actually made this into a full-blown game. Although I can't find it right now. And look, he made this one earlier. Oh, this is so good. Look at that. Incredible. Really incredible. So here's another one from W Gloss. This is pretty neat. There's some randomness here. Very cool. Very cool. Yeah. Vanilla, JavaScript, and DOM API. Here's one from Nita. Check this out. Whoa, what? That's crazy. Oh my gosh. Nita, you want to talk about this a little bit?
Yes, I can. Um, can I see the code? Because I don't remember it now. So I added animations on the Y position of the rectangle, each rectangle. Yeah.
Whoa. Dot animate. Fascinating.
Dot animate is a function that is used.
Wow, I had never even seen this method. That's very cool.
Yeah, I just researched a little bit and found this one.
Wow, amazing. Very nice. Very nice.
Thank you.
But how are they all going at? Could you mute yourself? Because my audio is bleeding. Now, how is it that each of these are not going all at the same time? It seems like it's the duration of this animate is a random number. That's really cool. Really cool. So that's how that effect happens. Very nice. And whoa, look at this one. Very nice. It almost looks like three-dimensional balls or something. Wow. Very cool. Very cool. Let's see. Oh, here it is. He posted again. This is the game version. So I was quite impressed by this. Check this out. You have This is so funny. You have to click when it's black and white. So I just got 1 point. And if you click when it's not black and white, okay, I clicked on black and white again. But if you click when it's color, you lose a life. See that? One less little icon there. So this is just through the roof. Really great job. Really creative. Very nice work. Here's another one from Nita. A bunch of circles. Wow. Beautiful, beautiful grid of circles. Very nice. Do you want to talk about this one at all?
Yeah, I would like to talk about it. So what I did here, we are actually positioning each circle in X and Y direction. So we are using I and J twice. So we can get the kind of matrix values in the matrix, I and J for each cell there. Something like that. You can say it is going in the X direction and Y direction at the same time. And
Beautiful.
we are getting the whole grid gets filled up depending on how many numbers of circle we are using. And you can add animation and other things on top of it. And I did it in other example. I kept forking it again and again. It was just so fun.
Awesome.
Awesome.
Thank you.
Thank you.
Okay.
Yeah, this is great. So it's a nested for loop where I goes from 0 to count, J goes from 0 to count. And for each combination of I and J, the circle is positioned. Very nice. Very nice. And it's pretty close to this other soloist piece. So that could be the next phase, perhaps. All right, that's it. That's all the work. Very cool. All right, any questions or discussion so far? If not, I think I'll dive into the coding. All right, here we go. Here's our piece that we made last time. I'm going to start by forking this, and I'll call it soloist reproduction with D3. All right. Open the editor. The first order of business that I want to do here is include D3 into our app here. One way to do that would be to add a script tag to the head and put the source equal to something, usually from a CDN like Unpackage. A CDN is a content distribution network that essentially hosts files on the web that you can pull in. However, in modern web development, usually you use a Node.js based build system, like using Webpack or Rollup, or using some starter app system framework thing. And there's a relatively new feature of VizHub that lets you approximate package.json, which I'm very excited to start using. So let's do that. I'm going to make a new file called package.json. Package.json, by the way, it's a standard in a way. NPM and the Node, NPM stands for Node Package Manager, It's a whole ecosystem of JavaScript libraries. And so NPM expects this thing called package.json. And you can put a bunch of stuff in here, like set the license and, add dependencies. Dependencies is what matters for us. So you specify this object that has dependencies and then the library name and the version. We can use this to pull in D3 to our program. In package.json, I'm going to make it an object in JSON format, JavaScript object notation format, JSON. And the key will be, oh, there's something strange happening. All right, so we can type dependencies as the key, and the object can contain D3 at some specific version. And let me check which version D3 is at. The way I like to check that is to go to unpackage.com, which is a CDN that hosts script files, and just type D3, and it will automatically fill in the latest version. So we're at version 6.6.1. So in here, D3 version will be 6.6.1. All right, that's like a bare minimum package.json. And then what we can do is introduce a script file where our JavaScript can go. And just by convention, I'm going to call it index.js. And what we can do is take all of this JavaScript that was in this script tag directly on the page and move it over to index.js. And everything still runs. Now I can delete that script tag over here, and we have this sort of new setup in which we can import from D3. So here we go. Let's pull in something from D3. I'm going to say import selection from D3. This is ES6 module syntax to import from packages. And this syntax you can use, again, with all the modern templates and whatnot. And so let's see if this worked. Console.log selection. I just want to see, did it get defined as anything? In the dev tools, we can see that indeed, it's a function. Hooray! It's a function from D3. It's got these weird characters because it comes from a minified file, the D3 build. But anyway, this means that now we can start using D3. So let me talk about selection. If you Google D3 selection and click the first result, it's the documentation page for this package called D3-selection. And D3, by the way, is structured as a collection of many smaller packages that are all composed into this one monolithic library called D3. And so if you see in D3 itself, it exports things from all of these D3 packages, which you could use on their own. But for convenience sake, I'm just going to pull in the whole D3 build, which contains all of this stuff. But anyway, D3 selection is one of these things, and I'm going to pull in from there. And feel free to stop me at any time with questions, by the way. Yeah, I haven't really introduced D3 itself. Let me stop and do that. Since this is this first time that we're pulling in D3, I thought I would take a moment to discuss D3 and why we'd want to use it. Overall, just some broad context for this. D3 stands for Data-Driven Documents. It refers to documents as in the HTML document object model. D3 has utilities for DOM manipulation, which we did last time with the vanilla JavaScript API for DOM manipulation, which was quite verbose. A lot of that stuff can be changed such that it uses D3 for DOM manipulation, and the code will shrink down. It'll be a lot simpler to read and use. In addition to DOM manipulation, D3 has all sorts of utilities for building data visualizations. So that's why it has become sort of the de facto standard for building visualizations on the web today. The whole rest of this series is going to be diving into using D3 to make all these different types of visualizations. But as a starting point, I wanted to introduce D3 in a way that's disconnected from data and all the complexities that comes along with data in this SoloWit exercise here. D3 selection is the package within the set of D3 packages that does DOM manipulation. Here are some examples of how to use it. And I'll go, we'll craft these ourselves. But for reference, this page is the canonical documentation for D3 selections. All right, now that we've imported selection from D3, we can start to use it to replace this code that we had from last time. So here's what I'm going to do. I'm going to comment out everything and then re-implement it with D3 one block at a time. The first block to consider is the one that sets up the SVG element. I'm going to comment this out as well and replace it with some D3 based stuff. Select body is what we need to do to get a D3 selection of the body element. And now that I think of it, we really need to import select from D3, not selection. So we've got select from D3, we select the body, and a D3 selection instance is this sort of complicated thing that we'll be learning more about. But it has this pattern of using it called method chaining, where once you invoke something and you get a D3 selection back, that thing that gets returned by this function has a bunch of methods on it, one of which is append. And you can pass into append the tag name like SVG. And that returns the selection of the SVG element that was appended to the body. So this one line here does the exact same thing as this line and this line. It creates a new SVG element and appends it to the body. To set these attributes on this, well, first of all, let me save this as a variable. I'll call it SVG. Once we've got that, we can say svg.attr, which is short for attribute. Internally, this actually invokes set attribute. And the signature is compatible with the vanilla DOM API method set attribute. So I can just paste this stuff here. We set the attribute of width to be the value of the variable width. And same thing for height. The height attribute gets the value of the height variable. Now we can inspect the DOM to see if it worked. And sure enough, there it is. There's an SVG element with width 960 and height 500. Any questions at this point? All right, so this is one way to set up the SVG element. Due to this method chaining thing, you can actually combine these together into one big statement. So instead of having multiple different statements, it could be one giant statement where we chain these things together. So we append the SVG, and then on the selection of the SVG, we set the width and height. All right, so we've got our SVG set up. The thing that I wanted to do next was add the rectangles that are in the background. That would be a good next thing to add. Yeah, this block here, where it's a for loop that adds a bunch of rectangles, let's do this with D3. So I'll bring that up here. The way we would do this in D3 is we need to have an array to work with. And then once we have an array, we can use the D3 data join concept. So here's what we can do. I'm going to use this code as a template to build up an array of objects where each object represents the attributes of a single rectangle. So I'll paste that, uncomment it, and then I can initialize an array. I'll call it marks because it represents the visual marks that are going to appear on the page. I'll initialize it like this to an empty array, and then in the body of this for loop, instead of creating DOM elements, I'm just going to push objects onto this array, meaning, append them to the array, add new entries to this list of things by using the push method. So we can say marks.push and pass in an object literal. And on this object literal, I can build up all the things that it needs to know to render a rectangle. So y, for example, could be set to I times 20. Width could be set to width. Height could be set to 10. I'm just copying from what's there. And the mask can be set to this string here. That's how we can build up an array of objects that describe the rectangles. This is not using D3 at all. This is just pure JavaScript. And just to see that it worked, let me console.log marks. Sure enough, we get this array, and we can see it's got a bunch of objects where the only thing that really varies is y. All right, so far so good. You have a question?
Yeah, so we are doing this because D3 requires an array as a data, right?
Yeah,
Yeah,
that's right.
that's right.
Um, your audio is really bad. I don't know what it is, but maybe grab a camera or something. The reason why we're setting up this array is because D3 expects an array to work with, to use this data join feature of D3, which we're going to use right now. I'm going to refer to this SVG selection from earlier to add rectangles inside of it. And to use this pattern of D3 data joins, we can take a D3 selection and say, that selection dot select all rect. This makes a selection of all rectangles that are on the page already. And at the point where this code runs, there are none. But the fact that there are none is useful information to D3 because it knows that, okay, the set of DOM elements on the page, it doesn't contain what it needs to, therefore I have to add it. So once we've said select all, we can say dot data marks. This produces a D3 data join that has a bunch of methods on it. One method, which was added fairly recently in D3, is .join. It's a simplified API to the other stuff that was in use before, like .enter, .merge, sort of stuff. And we'll get deeper into this, but this is the simplified API that we can use for our case. So what it's going to do here is create one rectangle for each of these marks. And then on this selection that contains all these newly minted rectangles, we can set some attributes. We can set the attribute of, I'm looking at this object here. We want to set all 4 of these attributes. We can set the Y attribute to be, well, what we want to set it to is the Y value from the corresponding object that was constructed over here. To do that, we can accept a function as input to the second argument to .attr. And that function can take as input D, which is the datum. It's just a convention to use D to represent the datum, like one row of the data, or one entry in the data array. And that can return D dot Y because we've set it up here. So when we access D dot Y, it's going to access the Y value that we set up over there. And we can do a similar thing for all the other attributes that we need. Width, we can set it to d.width. Height, we can set it to d.height. And mask, we can set to d.mask. And that's not doing anything now because I commented out the actual masks. And as you can see, it worked. We've got our rectangles back. This is how you can use D3 to create a bunch of rectangles on the screen. Now, this duplication between here and here is not ideal, but I kind of like this way of doing things in a sense because it decouples the computation of the marks from the rendering of the marks. This here, it just creates an array of objects that we can directly pass in to all this D3 logic over here. And I like this setup because if in the future you ever wanted to change what you were using for doing the DOM manipulation, you could. And this part wouldn't have to change at all. The only thing that would have to change is this, like if you wanted to render it using React or Vue, for example, these other DOM manipulation frameworks. But this is not often what you see. So often what you see is it's all combined into one big block. And in a sense, that's more efficient because there's no need actually to create all these strings if they're all the same and then refer to it here. You know, we could just pass in the value right here. So what I'll do, I just wanted to show you how that looks. So I'm going to comment out this so it's there as a reference in the future, and then refactor this to use the more common pattern that you find with D3, which is to compute all the values in these accessor functions. So instead of doing all this stuff here, I'll do it down here. And if we're doing it like that, we don't actually need all this logic to build up the array. We can use a utility from D3 called range, which creates an array. Range of, say, 5. It creates an array that has 5 integers in it that start at 0. And to use this, we need to import range from D3 along with select. Now that we've done console.log range of 5, you can see that it did output here that array that just contains some numbers. So this is the data array that I'm going to use now as the input. Instead of saying .data marks, I'm going to say .data range of 5. But we did have this variable called n, which is the number of rectangles, so I'm going to use that instead. Now, in here, instead of accessing the properties that were on those objects, we can compute those values on the fly. D is the number in this case, so I'm just going to say D times 20. It can take the place of I. And for these other ones, I'm just going to return width and 10 for height, and then this string of the circle mask right here. And since these are returning the same values for each rectangle, these don't actually need to be functions. We could just pass in the value directly like this. This highlights an important aspect of this .attr method, that it accepts either constant values like this or functions. And when it accepts a function, it passes in the object from the array into that function, and then whatever that function returns, it's going to use as the value for that attribute. All right, so we've got this far. Let's keep going in our refactoring of this code here. What does this block do? It creates a mask, and it sets the ID to be circle mask, and it appends it to the SVG. We can do the same with D3 by saying svg.append mask, and we want to set the ID attribute to be circle mask. All right, that should do the same thing as this block of code over here. I don't know why it's not showing up our rectangles though. Oh yes, because now that mask exists, but it doesn't contain anything yet. It doesn't contain those the circle or anything. So that's our next step. The next block of code adds that background rectangle of the mask. Well, let's do that now with D3. That would look like mask.append. Although we don't have mask yet, I'll just define that here to be that D3 selection of that mask element. So now we could say mask.append rect. This one statement does the same thing as this statement here, which creates the rect element and also appends it to the mask parent. Now we can set the attributes width, height, and fill. And if I change this to white, it should show up all of our rectangles, and it does. Okay, but black means hide the rectangles. This next block does the same thing, but for a circle. So I'm going to copy that logic for the rectangle and change it to be for a circle instead, where we set the CY attribute, we set the CX attribute, and we set the radius attribute. And finally, we set the fill attribute of that circle. All right, and the mask is working again. Fantastic. Now, let's do the same for mask 2. Now remember, mask 2 was all the same stuff as mask 1, except just the colors were inverted. So we can copy this whole block of stuff. Mask 2, oops, is a new mask that has the ID circlemask-2. And then we append a rectangle to mask 2, and instead of it being black, it should be white. And then we append the circle to mask 2 down here, and the fill of that should be black instead of white. Okay, that seems to be working, although I forgot to change it to mask 2. So I'll change that now. Mask2.append, mask2.append. All right, and lastly, we have our rectangles, which I'll bring up to the top near the other rectangles, just so all the rectangle stuff is in one spot. So I'll paste that here, and it's almost exactly the same as this block of code that we did for the first set of rectangles. The only difference is that x gets set to I times 20, so I'll just change this y here to x. Width gets 10, height gets the value of the height variable, and the mask is circlemask-2. Okay, see this breakage. This is not what we expect. See that? So does anyone have any idea what's going on here? See, what appears to be happening here is that this first chunk of code that made these rectangles, it set up all of these rectangles properly, but this next block of code that deals with rectangles, it actually selected all of the rectangles that were there from the first block of code. And then it set the x value of that, and it set the height value. So it's just sort of a mess where our two different blocks of code are, impacting the same set of rectangles, which we don't want. So how can we make it so that these two different blocks act on different rectangles? Well, there's a couple of approaches. One approach is we could use classes to differentiate them, and another approach is we could use group elements to contain them. Let me show you how both of those would play out. If we want to use classes, we can set the class attribute to be something like maybe horizontal. And then when we say select all, we can say rect.horizontal to only pick up on those horizontal ones. And it's still broken because we haven't done the same treatment for the other set. But we could say class is vertical over here, and then we select on the vertical rectangles only. This is one way of doing it. I'm going to fork at this point just to have a reference of that state of things. Okay, so this is one way of doing it, using classes. Another way, I'm just going to put it back to the way it was. Another way of solving this problem is to use group elements, where you could say svg.append g first. And that way, it would only be working within this newly appended group element. And an SVG group element it's a very useful element. It just groups its children together in the DOM tree. And let me do the same for the other set. Okay, now you can see it's not broken anymore. And if we inspect the DOM, we can see that there's one group element that contains the set of rectangles going from top to bottom. And then there's an entirely other group element that contains the rectangles going from left to right. Yeah, and the reason why this works is because the selection for the rectangles only acts within each of these different group elements. So that's another way to solve that breakage. Okay, very good. This feels like a milestone. From here, I'm going to fork this and try to reproduce that the full set with the different shapes. Any questions at this point?
Yeah, just a couple. The attributes, the ATTR, just so to get it straight in my head, the second arguments to the ATTR methods, those effectively match a data point in the your array and put it on the screen, basically. That they attach some kind of pixel point to that data point. Is that the right way of thinking about these arguments that are passed to ATTR?
Yes. Yes, that's correct. That's exactly right. So whatever we pass into .data should be an array. And the .attr applies to all of the DOM elements in that selection. And so after we call .join, the first time this runs, I mean, it's not running multiple times, but when it runs, it's going to create a bunch of rectangles. And then for each element of that array, it's going to pass that element as the argument to this function that we've passed in. And so the responsibility of this function is to map that entry in that array, whatever it may be, whatever shape it may be, onto whatever is expected for the x coordinate in this case, or in general the attribute value of the DOM element. And so yeah, it's a mapping function that essentially transforms the thing from data space, whatever that may be, into, well, I like to think of it as screen space. In this case, the x coordinate, so literal position on the screen. But it could also be a color or width and height, like these cases here. But yes, that's exactly what it's doing.
Thank you. Yeah, that makes sense. And the earlier chunk where it talks about, append G and select all and data. Are these, so just so my mental model is correct, or as close to correct as possible, it's creating a brand new selection at that early stage, and what the ATTRs are doing are modifying that selection. Is that the way to think about it?
Correct. Yeah, some of these lines create a new selection, and others of these lines modify an existing selection. There was, in the past, I mean, it still is, there was a convention around indentation relating to this point. And that convention was any line that creates a new selection be indented one level, and then any line that modifies modifies the selection that was defined on the line above should be indented by 2 spaces. However, that's sort of fallen out of fashion because everybody's using prettier nowadays, but it's a nice touch. And just to really make it clear, let me walk through each and every line of this. svg.append G creates a new group element, a DOM element. Internally, it invokes exactly this code of, document.createElementNS with the SVG namespace. And it takes that DOM node that was constructed and associates it with this newly minted D3 selection that didn't exist before. And it creates a brand new selection. So the return value from svg.append G is a selection that just contains that one group element. When you say .select all rect, this creates yet another D3 selection that happens to be empty. It's an empty selection that would contain rect elements if there were rect elements there, but there's not. This information, the fact that it's empty, is very useful to the internals of the .data method, which associates an array to that selection. And at a certain point, selections were made immutable, which is a really nice feature of selections. Selections are immutable. So the .data call creates a new selection where that empty selection of no rectangles is associated with this data. All right. And then when you say .join rect, this is actually a short form of another pattern, which I'm not sure I totally want to get into, but essentially it's .enter .append rect. And so the enter selection handles the case where there's no DOM element on the page corresponding to a given data element. And so for each of those cases, it will append a new rectangle. So that's this .join is a short form for that in this particular case. And then all of these lines that use .attr, they don't actually mutate the anything in JavaScript. Like so the D3 selection of these rectangles is immutable. However, what it does when this line runs, it goes through each and every DOM element and it mutates the DOM element. It sets the Y attribute to be the return value of whatever the value is returned from this function. And same thing with all these others. It goes through and updates the DOM elements based on the return values. So I hope that clarifies the role of the different pieces.
Definitely. Thank you very much.
My pleasure. I see there's some questions in the YouTube chat. Did join used to be enter rect? Well, no, it used to be .enter.append rect. And join, it actually does something with merge, but we'll get to that later. Another question from the YouTube chat. Since mask height and width are the same, can you bind them to a parent G element? That's interesting. So the mask width and height are applied to the rectangle within the mask, not the mask element itself. Therefore, no, I don't think you can do that. I don't think you can do that. All right. I'm about to dive into a whole other section. Maybe let's take a quick 5, and then when we return, I will go all out in trying to build this thing. All right, yeah, let's take 5. See you in 5 minutes.
there, you don't answer them.
No, in audio form.
But audio doesn't work. You are frustrated with my audio. It's not working, you say.
Well, now it
You
should be
didn't
working.
move it.
Now it should be working fine.
And my questions are right here. If you could check every 15 minutes questions, it would be really nice. My doubts will get clear.
Well, now that you have good audio, you can just ask me without. All right, I'm back. Before we move on, are there any final doubts about what's happening so far?
What are we creating exactly?
Oh. We are creating this piece with the shapes. Yeah, in order.
Okay.
Yeah. And in order to have the flexibility to do this, I've started to use D3 because it's going to make it a lot easier. Well, it's going to make it possible. If we were to try to do it with the raw DOM API, it would be, really a big mess. Okay, here we go. Let's fork this one. And I'll call it full solo-wit reproduction with D3. The first thing I'm going to do here is just delete all this junk that is left over from earlier. Deleting all these blocks that are commented out. All right, now we're left with this program that is 62 lines of code. What we can do next is change this mask to be a shape. And D3 actually provides a set of symbols that we can use. There is a package called D3 Shape. And in D3 Shape, there is a section on symbols. These symbols here are provided by D3. And the way this plays out is that you call some D3 functions and it generates for you the string to use as the D attribute for a path. To create one of these symbols on the screen, we need to just make a path element and then set the D attribute to the return value from some invocation. Let's see what that invocation would be. We have to call d3.symbol and pass in type and size. The type that we pass in should be one of these symbol types like d3.symbol circle, d3.symbol cross, d3.symbol diamond. Also, the set of symbols is exposed as d3.symbols. This is an array that contains all of these individual things. And so since our aim is to reproduce this piece, which has a bunch of different symbols going across, I'd say we can just use that array of all the symbols that are available and, traverse it. Use that as our data. All right, so let's import symbols from D3 in our code. Import select, range, and symbols from D3. We also need to import symbol from D3. The way we use this is we call symbol, passing in a type and a size, and that returns a symbol generator, which we then need to invoke with some arguments, or no arguments, I guess, works. And that there's just something complicated that you could do if you pass an argument, but you don't need to pass an argument. So once you invoke this function, it will return that string that we can use as the D attribute of a path. So let's give it a shot. On one of these masks, I'm going to replace this circle with a path. And instead of CX, CY, and R, we can set the D attribute to be symbol. And I'm going to pass in the symbol type, which I can just access, symbols at index 0, the first entry of the symbols array. And the second argument here could be the size. I don't really know what the range of size is. I'll try 300. And this invocation here returns a symbol generator, which we then need to invoke as a function. And once we do, it should return some stuff. All right, I don't see anything. Maybe the size needs to be increased. There it is. I see something start to appear. Yeah. Okay, there it is. The first symbol happens to be a circle. But to see some other shape, we can access, I don't know, the next symbol, symbols at index 1, for example. Notice that the symbol is centered in the upper left. That's, I think, the first problem I would like to address here. Yeah, and the way we need to do this is, well, we want to move it around. My first goal here is to move it so that it's in the center. And to do that, I think the most straightforward way would be to use an SVG group element as the parent of this path and transform that group element, meaning move that group element around with everything in it. Let's try that. All right, so here we've got mask.append path. But instead, what if we did mask.append g.append path? This works just the same as it did because it's just a grouping with no transform applied to it. To apply the transform to this group element, to move this path around, we can say .attr transform, and the value will be translate of, let's just try some numbers, 400, 400. Yeah, that moved it. The way this works is it's a string, but it looks like a function invocation. It's a domain-specific language for transforms. And what it looks like is the first argument to this function-esque kind of a thing in a string is the x coordinate. So it's going to move it over to the right by 400 pixels. And the second argument here is the y coordinate. So it's going to move it down by 400 pixels. Ideally, to put it in the center, we could say width divided by 2 and height divided by 2. But since this is a string, that's not going to work. We can take advantage of an ES6 language feature called string template literals. And the way we can use this is by using backticks. And then inside of this thing, we can bust out into JavaScript using this syntax here, a dollar symbol and then a pair of curly braces. So now whatever's inside this pair of curly braces will be evaluated as JavaScript and inserted into that location in the string. So now we can actually use width over 2 and height over 2. And now it's dead center. Look at that. I'll bring the size down a little so it fits on the screen. There we go. All right, so the problem now is that one of these masks uses this symbol and the other mask still uses the circle. So, I mean, one thing we could do to address that is copy paste all this code, which is what I'll do for now, and change white to black. All right, now this sort of is starting to resemble that SoloWit piece a little bit more. But I hate this duplicated logic between these two blocks, these two masks. I mean, there's a bunch of code that looks almost exactly the same. The only difference is one of these is filled with white and has an ID of circle mask, and the other is filled with black and has an ID of circle mask 2. And now that I think of it, these names are a little outdated because it's not circles anymore. So I'm going to rename it to mask 1 and mask 2. And I have to go and update the references as well. Okay, now what I would like to do before we go any further is refactor this so that there's no duplicated logic. The reason being, once we start adding more shapes into here, we're going to have to copy paste larger and larger chunks, and if we want to change it in one place, we'd have to change it in 2 places. It would be a total nightmare. And so this is a point at which refactoring makes a lot of sense. refactoring is this notion of reorganizing code so that it's more maintainable, or you can do more things with it. Generally, refactoring is triggered when you see duplicated logic in your code. All right, so what I'm going to do here is define a function. And the idea is we can invoke this function and we can pass in only the things that vary between the two, namely the mask ID, which is different, and the fill, which is different. So let's try that. Const, what should I call it? Render mask equals a function, and I'm just going to take all this logic that appends the rectangle and the path and put it inside these curly braces and use Prettier to automatically indent that. Now, the things that we want to accept here are the ID and the fill. But first of all, we should actually invoke this function. Okay, now everything is in working order again, and we can take as one argument here the ID of the mask, and we can use it here when we're setting the ID. So I'll say render mask and pass in that string mask-1 here, which surfaces inside of this function as the local variable called ID, which is used here to set the attribute ID on the mask. Right, so we can actually now call render mask twice, passing in different IDs. And I'll just comment out this other block because it's going to be replaced by this function. All right, so the fill is the other thing that we need to have vary between these two function calls. So I think what I'll do is instead of white, this will be fill, which we can accept as the second argument. And so what we can do here is pass in white to the first one and black to the second one. Although this is not exactly right because we also need to deal with the background rectangle, which needs to be inverted. Like if it's black, it needs to be white. So you know what? Instead of using fill, I'm going to accept an argument called inverted. And this will be a Boolean where if it's true, the colors should be inverted. If it's false, they shouldn't be. And so inverted for the first invocation should be false, and for the second invocation should be true. And then we want the rect fill to be black if it's not inverted and white if it is. And to do that, I see there's some YouTube chatter. Let me finish this thought and I'll answer some questions there. To do that, the tool that I would reach for is the ternary operator. So we can say inverted question mark. If it is inverted, this should be white. Otherwise, it should be black. Since this is the first time I'm using this, I want to stop and show you what it would look like without this syntax. It would look kind of like this. Let rect fill equals black. And then we could say if inverted, rect fill equals white. And then we would use rect fill down there. So what it's doing is, if it's not inverted, this code will not run, and rectfill will be black. But if inverted is true, rectfill will be white, and this will be filled in with white. However, I think the cleaner syntax would be to use the ternary operator and say if it's inverted, it should be. See, now I'm losing track of what should it be? Let's say black and white. Now we can apply the same logic to the fill of the path, but it should be inverted from the background. And so if it's inverted, now it should be white if it is and black if it isn't. Okay, there we go. Victory. Now we can get rid of this commented out stuff here, and now there's just one block of code that is responsible for rendering this mask. The first time we render it as mask 1, which is not inverted, and the second time we render it as mask 2, which is inverted. And at this juncture, I want to introduce the syntax of calling functions on D3 selections. What that looks like is it can take, this is just a convention that I want to introduce now. It's a convention that's used when you start to use functions to abstract, to build abstractions in this D3 world. So what it looks like is we pass the selection as the first argument, and inside of this function we refer to it generically as some selection, and we would pass it in as SVG here as the first argument. Now everything works as expected, and the conventional way of doing these sorts of invocations with D3 would be to use selection.call. So we could say svg.call render mask, and then pass in these second two arguments here, like this. And we can invoke it again with these other arguments. These two are exactly equivalent in terms of what they do. I just wanted to introduce this way of invoking functions on selections. It doesn't have any immediate benefit right now, but it can be a very nice, elegant way of doing it. One of the reasons being that you can chain it like this. So this is also valid syntax. All right. So I'll fork from here just to capture the state of things. Now the task before us is to render multiple symbols in here instead of just one. So how can we do that? Well, we've got symbols at index 1 in use here, and what we essentially want to do is iterate through. So if I change it to be symbols at index 2, the shape that you see is a different shape, and symbols at index 4 is a star, for example. What we want to do is append multiple paths where each path has this D attribute from a different symbol. So how can we do this? Instead of just appending a single path, we can use this data join pattern that we used earlier with our rectangles. What this looks like is, well, instead of doing it on the end of here, I'm going to assign a variable called G just to sort of separate these concerns here. So G is our parent. We can say G.select all paths, and initially it's going to be empty, dot data. And what should the data be here? What I'm thinking is it can just be the same thing we did with the rectangles. We can use the range utility to create an array that contains integers starting at 0. And how many things should be in here? Well, it should be the same as the number of symbols that are available, which we can access from symbols.length. All arrays have this .length property, and it returns to you the number of elements that are on the array. All right, so we've got this array of integers going from 0 to the number of symbols. So now what we need to do is use this .join method on paths. Now it's going to create a bunch of paths. And on each path, we want to set the D attribute to be something like this that we had earlier, but we want it to vary based on the symbols. And we also want the fill to be white or black. Since we are making multiple paths, we can use a function here to take as input D, one of these integers, and we can access symbols at index D to have it be different symbols. And what we get here is like this giant splotch where all the symbols are right on top of each other. So the task at hand here, now that we've got this far, is to split these apart in the x direction so that, one symbol's on the left and one symbol's on the right. Since we have D as an integer, that starts at 0 and goes upward, we could potentially move each of these group elements over if we had them, but we don't. We're just creating path elements. And there's a containing parent group element. I think what we really want is to have it so that for each symbol, there is a separate group element created, and then within that group element, there should be a path. Yeah, to clarify what I'm saying, if we inspect the DOM here, we can see that within the mask, there's a group element that has a transform, and then within that group element, there are a bunch of paths. I think instead, we want to invert this containment relationship where for each symbol, there should be a parent group element that gets a different transform, that gets translated differently in the x direction, and then within each one of those group elements, we can put the path. Yeah, that's what I'm going to go for. And we could keep this parent element, but I don't think it's necessary because we could just set the transform on the inner elements. So I'm going to get rid of that for now. And instead of appending our paths to G, I'm going to append them to mask. Now it's working again, but it's in the upper left corner because they're at the origin now. The next step here is to use group elements instead of paths. So I'm going to say mask.selectAll G, dot data dot join G. However, this this convenience method is no longer enough for this case that we've got. Now we need to deal with this concept of the enter selection, because what we want to do is tell D3, whenever you create a new group element, you should also append a path element inside of it. Yeah, and to do that, we need to use the join method in a slightly different way. What we've seen so far is the shorthand of join, where it accepts a string, being the tag name. But the long form of .join is where it accepts arguments for enter, update, and exit. And I'll get more into this later. But the simplest form of this is we pass a function to .join, and it's interpreted as the enter selection. Actually, more precisely, we need to pass a function that takes as input the enter selection. All right. I realize it is a little confusing. And in here, we can say enter dot append G to create our parent group element, but on this, we can say dot append path. And then on these paths is where we can set the D attribute and the fill attribute. Okay, we're back in working order. Just to walk through this one more time. We're passing a function to .join. That function will be invoked with the enter selection of this data join. And because there are no group elements initially, the enter selection will have this append method that will get triggered for each and every entry in the array. So we append a group element, and we append a path element to each of those group elements, and we set D and fill on each of those paths. So now if we inspect the DOM and look at it that way, we can see that there are indeed many group elements. It's just that what we need to do now is transform each of these group elements to translate them so that they're in the middle vertically, but they're spreading across the page horizontally. And I see in the YouTube chat, Vani says, use this code right here. Okay, I'm going to copy that code and see if it works. Thanks for that. I'm just pasting this from the YouTube chat. Oh, that's what I've got already. But yes, that's correct. That's correct. All right, what we want to do here is for these group elements, we want to set the attribute of transform to be, we can take this thing that we had constructed earlier, translate by width over 2, height over 2. Okay, now it's in the middle again, but we don't actually want to translate in the x direction by width over 2. We want to translate in the x direction by some function of d. And keep in mind, d is an integer that goes between 1 and however many symbols there are. Let's just say d times 200 to like spread them out by 200. Oh, but this is not a function. It's just a string literal. So let me make it into a function that accepts d. Okay, there we go. There we go. All right, it's starting to come together. That looks like pretty cool abstract art right there. Oh, Vani says it's not the same. It uses I. Let me see that. Let me take a look at that. Yeah, so this is the code that I wrote. This is the code from Vani in YouTube. It is slightly different. It accepts I. Yeah, this when you pass a function, it does take a second argument, which is the index in the array. So this works as well, just the same. However, it just so happens that the array is integers that would be the same as I all the time. So that's why this variant works. But anyway, we can just tweak these numbers to make it so that different shapes show up at this point. So they seem to be a little too large. What if I say, the size is 50,000? And by the way, I think this size is like the number of filled in pixels. I don't know. It just they're high numbers, but I don't know. This is just what it takes. So I'll bring down the size until we can see multiple shapes. There we go. Starting to come together. And I'm just guessing here at the this constant that will split them apart. Can make it even smaller. All right, this is almost there. Look at that. Beautiful. Beautiful. Any questions at this point?
So the example of the join in this case, that was a case of appending elements to multiple elements, which was different from before. Is that right?
Correct. Yeah, it's a slightly different pattern, and it's using the long form of dot join so that we can access the enter selection. Yeah, so it passes in the enter selection, and the enter selection is populated with the case where there is no corresponding group element for a given data element, which is the case for all of them when this runs. That's why enter.append g will append a group element for each and every entry in our array here, for each and every symbol. And then, after appending that group element and setting the transform, we append to that group element a path. And then .attrd, this whole thing works because of the way D3 is set up. It actually uses the data element that was bound to the parent. So that's why this works. The data element D, which is one of those integers, is associated with the group element. And then if you append to it, if it came from the enter selection, you can reference those data elements from the child. So that's why this works. And I realize it is a lot at once in for today. But that's sort of the intention, to just like show, the scope of this D3 data join thing, and it will hopefully become more clear over time. But does that answer your question?
Yes, thank you. Yeah, that's really clear. Thank you.
Nice, nice. And by the way, this dot join method is new to me. I mean, I learned really well the old syntax with the dot enter and the dot merge. So for what it's worth, I really only learned this pattern recently, and I'm still sort of trying to wrap my head around it. So yeah, feel free to interrupt me as I go and ask questions like this. This is great. This is great. Oh my gosh! Oh, look at it. What time is it? Hang on. Oh, look at the time. I'm overtime. I'm so sorry. All right. Well, we've got pretty far for today. I just want to wrap this up by tweaking these numbers a little bit so that there's some space along the side. See how this circle is right up against the edge there? I can just add some constant to this, like 100. Yeah, that looks decent. And then I'll bring this number down so that there's some space on the right. Yeah, like 125 or so. And I'll bring the size down just a bit to make sure that we can see all the shapes. And in VizHub, you can set the height. So I'm going to make it maybe 200 pixels so that it more closely resembles the original piece. Okay, there we have it. There we have it. That's all we're going to do for today. I will leave it as an exercise. To make the sorry, scratch that. To make the background rectangles match the original Solowit piece. So here's your exercise, and this is kind of a challenging one. See how in this original piece, each subsequent square reorients the lines. However, in our example, what we've done is they're all the same. So that's one thing you could do as an exercise. Alternatively, I would encourage you to use D3 to try to reproduce any other Solowit piece, because now that we have this this new tool in our toolbox of the D3 data join, it'll become a lot easier to reproduce these Solowit pieces. Or create art, just generative art in the spirit of Solowit. And just as a reminder, here's some other Solowit pieces that you could do with the tools that we have now, the SVG mask and the paths. This one, for example, could be done with nested for loops and math.random to produce the points. So yeah, that's all for today. Thanks everyone for joining, and I'll see you next week. Take care.